Exploitation is the most effective way to get ahead. I'm Dr. Kyle Grokowski, and in this series, I distill research down to its core. I live for the feeling of discovery. That's why I became a scientist. Though I, like many of you, do really like watching Netflix. So I came up with a win-win situation. By explaining what I learned to you, I end up overriding my Netflix procrastination circuit, with the end result being I get to learn about something new I find interesting, and you get to learn about state-of-the-art scientific research that at least I find interesting. When you go to learn something new, you have two options: exploration or exploitation. If you decide on exploitation, who are you going to exploit? Will it be the best performing member you find, or will you follow the crowd? This work was done by Daniel Barkoczi and colleagues from the Max Planck Institute for Human Development and published in Nature Communications in 2016. This question on how to exploit for your own gain happens all the time. You go through these steps when you're stuck on a homework problem. Should you ask the smart kid or ask a couple of your friends for help? In business, this comes through innovation. If a company develops a groundbreaking product, does your company exploit it and make something similar? Or do you take a more balanced approach, partner up, and develop a product that's more unique, but could ultimately fail? The authors used a computer simulation to test each exploitation method. To get our feet wet, we'll start with a single optimum case. First, we randomly scatter the people. We can use the person's vertical position as a performance measure, so higher is better. Now, running the exploitation behaviors, the best member strategy looks at 3 random people. If they find someone that's performing better, then they exploit that person and copy to their position. If they find that everyone's worse off, then they explore by themselves. Now, the competing method is the conformity strategy. This is like wisdom of the crowds. Again, you look at 3 random people, but then you move to the position where most of the people are. Here are the results for this simple case. In this plot, we have the average performance for 100 simulated people. The horizontal axis is time. The red line represents the best member strategy. The blue line represents conformity. Now, the cool thing here is that the best member strategy reached peak performance twice as fast as the conformity strategy. Expanding on that, we increase the number of optimal solutions, making the problem much harder to solve. We see again the best member strategy in red is the fastest, but then it levels off. The conformity to the group strategy is much slower, but ends up achieving a higher performance at the end. The thicker line represents a 9-person search. Now, at first glance, this doesn't really make much sense. As with 9 people, you should have way more information about who's doing better than if you had 3 people. I'm still trying to figure out exactly what this means, but I think it's something along the lines of having too many cooks in the kitchen spoiling the broth. Lastly, the black dots are if you ignore everyone, and the gray line is if you follow anyone. This gets back to my opening statement. You must exploit to win, as all the exploitation methods performed much better than going alone. Now, the real trick in life is figuring out who to exploit and when to exploit them. In this episode, I exploited the authors of this paper, you exploited me, and I think we're all better off for it. So if you want to learn about how different social networks affect this exploitation behavior, click the link below and read the rest of the paper. That's it for episode 1. Subscribe and share, and I'll see you next time.